Hello friend, welcome back to my channel. Today I'll show you how to set resource and limits in Kubernetes. The requirements to do these demos are the Docker and kind up and running your computer. And if you don't have this, please check the link below. I have a video how to install on Windows, Mac, and Ubuntu. All the steps will be included in my blog post in the link in the description. Let's go to the board. Okay, we have our Kubernetes cluster in here, and this Kubernetes have node 1, node 2, node 3, and node 4. And every single node have memory and CPU. And the pods in here, they use the resource from the node. Example, for this pod is using resource node 1. So how Kubernetes know where they can deploy this pod? They need to check the limits and the requests and see what the node have this the resource available for this pod. Example, I have one node and I have a new pod. In this new pod, they have CPU and memory. And when the control plan and we have the schedule, that's a pod running Kubernetes, they check like the resource in the nodes in the Kubernetes cluster, and they check whether they can put it this pod. Example, we have this pod in here. So you need to move that for here, and so Kubernetes moving this application for here. They check what is the best place to put it this pod. When you create a new pod, the Kubernetes check whether they can put it this pod in here. So they go to the control plan decide, oh, node 1s don't have space, nodes 2, oh, they have a resource, let's put it here. So that's why it's so important you create your pods to declare your resource for the pod. When we'll talk about resource and pod, you need to focus on memory and CPU. So you have memory and CPU for this pod in here. And you have two categories for CPU and memory. You have a request and you have a limit. Requests are what the container is guaranteed to get when they be created. You know, when you create this pod, they will have like one CPU, two CPU, or they have a 5 gigabyte memory, 1 gigabyte memory. You like is guaranteed. The pods just be created if they have the resource. If they don't have the resource, they don't go to scaling, and you have like a arrow. So show you the pods can be scaled because you don't have resource. Okay, I will give you a real example how requests and limits work in pods. My wife wanna buy a Christmas tree for our house for the next Christmas, and she's asking me like how much she can spend. I say like $100, and she's checking the website and check everything there. And so okay, $100 working fine for me. So she's just like okay, she can leave the house to go to buy the tree for $100. So the minimum for she's leaving the house and go to buy this tree is $100. So that's the request. So I guarantee when she's left the house, she needs to have the $100 because that's the price for the tree. But she's go to the store and see like, whoa, I like another thing. I want to buy this ornament for the door. So she's want to take this ornament, but whoa, she's just leave the house with $100. So how she can buy? So she don't have the money. So when you think about, she's have a credit card. So the credit card can save her. So she's have the limit for the credit card, $50. So the $50 she can use, that's the limit. So when you think about request and limit, request, you guarantee you have. Limit is something you have, but you can use and you cannot use, but it's good to have. So for guarantee, she's going to have $100 to go to the store to buy, but the limit is a credit card. She can use the credit card, and the limit for the credit card is $15 because you know, like she's want to buy this ornament for the door, so she can buy that, use the credit card. So don't forget, request is like your budget, the money you have to spend, and the limit is the credit card, like for emergency. So it's good to have, but you don't use it all the time. Okay, before you go to the demo, I need to give you this gold information. So you need to think about the priorities for your pods or your application. So if you have a high application and that's need to be available all the time, you need this resource. So you need to put the request limits the same number, because think about it, you need more resource, but for you guarantee like your application have the request and the limit, you put it both the same, equal, like I have the request and limits the same. So always I have the resource I need to. If it is a medium, you don't worry about so much about this priority for this application. You put it request and limits different, and like the request you put it the minimal and limit you put it the max. So the request, when you think about the order stop at scaling, I'm going to make another video about that, but they use the resource so they can out scaling, and the time they go to out scaling the pod, they have like the limit and they can handle the traffic. So the job or whatever you're doing this application, for the time the auto pod scaling scale. And if you have a low priority for this application, it's not something critical for your Kubernetes cluster, you can put in, you don't need to put a request in limits. They go to use what is available, and that's a way like you have the priority for the high, medium, and low in the resource in the Kubernetes. So let's go to the VS Code and check how this works. Okay, in the terminal, the first thing, let's clone my GitHub, YouTube, cd21, and code. Let's open the folder, yes, and go to open the VS Code. Here, open new terminal file here. Okay. Okay. So in this folder, I have my make file. Always I have my make file, so you can use to do all the steps you need. I go to have the deployments in here, and I have the kind and metrics in the folders in here. So everything you need, that's you'll be in the folder 21 for this video. So first one, make, create, cluster. So let's create our cluster. So I go to create the cluster. When it's done, I will come back. Okay, I create the cluster. So make, create, pod file. So I mean run kubectl, run nginx, the imaging, the port, try run, and I put that in this folder. So you go deploy me, app, and if you see, we have in here, and I don't have any resource in here. So I don't lose the time to put in the resource. Let's go to the pod, the another document in here, and I have the resource in here. I have the request. That's the minimum they need to start the pod, and you have the limit. So let's start this pod. So we make, apply, config pod, apply pod, apply pod. So now you make list. Let's see if you create the pod. So they start to create the pod. So in this time, I want to check the metrics. So I can make enable. Let's go to enable the metrics. The file they will go to use to enable the metrics will be in here. And in the cloud, they have that. We don't need to think about that. But because we're using the local here, you need to start the metrics for this Kubernetes cluster you have with the kinds. So let's go again, make list. So our pod is running, and let's check the metric. So make show, and let's see the resource for the node resource. So this start show the resource for the node. So let's again make show pod, make show pod resource. So you can see you have the 1M for CPU and 9 for memory. So you can think about here. So if you see the CPU is 500M, that is a half for core. One core have 1000 M. So if you have a computer with cores, if have 4000 M's. So in this 4000 M's, you can share this 4000 M. So now you see CPU, I use it just 500 M's. I'm gonna use the half a core. So okay, so you don't use the core because your CPU, and 9 is the memory. So use 9 ME for memory. So I have like these pods, they running, have the metrics, but let's go to create deployments for CPU and one deployment for memory. So I want to show you guys how you make a test to start to use the CPU and memory, and show what's happening if you use all the memory and what's happening when you use all the CPU. So let's go to create these two deployments, and deployments will be in here. For CPU is a gold application, little application. You have Docker file in here, and you have the deployment in here. So I use the deployment. I just have a service in here, just for make it easy for connect to do the demo. And you can see I have the resource in here, and the same thing for CPU and memory. CPU and CPU memory is the same, just a service, a deployment, the same application, but the different, they use memory, and the Docker file if you want to create this application in UA. And let's try. So make create, no, make create CPU. Let me create the CPU. So make create memory. So they're going to create these two deployments with the service. So make list. You're going to see they create the pods. You create a pod for CPU, and you create another pod for memory. So I have another folder here that's a simple folder. Is just Alpine with a sleep command in here. So that's I go to use for send some traffic for the CPU and for the memory. So let's go create more two new terminals. So let me change the name here. I put it the CPU one here, and for the other ones I'm going to put in memory. The name, just for you know, I mean run. That will be the test for memory, and for CPU that's going to be for memory. So now let's create the pod to send traffic. So make create traffic. So I'm going to create the traffic pod. So make list pod. So you go to see they create the pod. So make start app traffic. Can you just stall? Let me go back here. I need you added the app for traffic. So they go to install this application for traffic. So you can use that for generate traffic. So make add the traffic app, enter. So they go to install the application, and after that you're good to go. So let's make start traffic, and that's for memory. So memory Let's go to send some traffic for memory, and let's do the same for CPU. Oh, make start CPU, and you send like some metrics for that. So I go here and make show pods resource. Let's see the resource for the pods. So you see the traffic start, and they start send some traffic for CPU and memory. You see the CPU is starting here. They start using more CPU, and the memory they just using 9 amps for the memory. The memory is not here. So let me see. Make list pod. Memory is there, but they start to restart because I think I put the traffic, a lot of traffic for that. So let's put in less for memory so we can have more. And one. So let's go back to memory, stop, and you can see like the results. So we don't have good results for now. Run again, and let's go back in here. So make the spots, and here the running, the memory is running okay. So make show pod resource. So let's give a time for the stable memory again. So they take like 40 seconds to send like requests again. So let's wait a little bit. I know they stop there. Memory, they start sending, you see? Memory here. So I think that's no breakdown right for now, but you have like all these pods running. So make and list pods, and you can see you have memory back. So you see like when you send requests for the CPU, they continue working fine, but then send a lot of requests for memory, and the memory, they start to use a lot of memory. So that starts to break down the restart the pod. So I will go choose another script for CPU and memory because I want to try to break memory CPU, and I try to break memory. So let's go back in here. So make break memory, like memory. Let's go to try break memory, and like start make break CPU. Okay, I'm sending requests for CPU, and I'm sending requests for memory. And let's see, I'm send 100 requests for CPU, and I just send 100 here, and I just send 7 for break memory, and 7 to break 7 you'll be 7 cores and 7 threads for this test. And I send like the connection for memory, because memory is the name for the service I have direct for the deployment for CPU and deployment for memory. So let's go back in here, and you let me show two things. Pods resource, and you see like they don't show resource for memory, because if you go here, like they go to restart again. So this pod, and you see they start to restart again. So when you have a pod and this pod use so much memory, the pods start to restart, and like Kubernetes start to use like all the memory they can. They try to handle it, but they can't. So the only way like they think they can fix this problem is restart the pod. So the pods go to be restart. So you don't have more limit to use all the memory you have. So they go to restart. But CPU, they don't go to restart. They go to continue running, but they start throttling and the throttling, this go to slow, and like you request coming and take more time, or start sending like 500 problems, like service problem, or break the connections, but the pods never go to restart. They just go to be slow, because like in CPU, they have a different way to fix CPU. They try to use all the CPU you have and keep it like slow, but they never go to restart your pod. But memory, they go to restart your pod all the time. So let me go to stop now. And before I stop, let me go to the last time to check how much resource you have. So you see, they use all the resource you have in here for CPU. And like you can see in the CPU, how much you have there, you go to have 2. That's the limit. They never go to pass the limit. Okay, you can see the CPU continues just the same limits we put in here, but the pod never restarts. If you came back in here, so make this pod, the pods continue running for CPU, and the memory crash back. So if you go to here, so cube, describe pod, and put in memory. So they'll give you like some information. But the thing we really need to check is in here. They're going to give the results. You see termination 0137. Let's say you use so much memory. Okay, don't forget to close your terminals, and the last thing you need to do is delete all. They're going to delete the kind cluster and all the resource. You need to set the resource in the limit, but don't forget to create the orders of pod scaling. But I will talk about that in another video, because orders of pod scaling is the way, like when you start have some load in your pod, they start creating new pods for you. And if you don't stop using that, they start scaling down. So, but that is another video. If you like this video, please subscribe to my channel and enjoy it. And I see you in the next one.